Okay, I'm going to try to do a quick video walkthrough of our mag driver tester, what I have where it stands right now. So this is the rig that actually goes into the chamber. We've got a plexiglass lid, a holder for the EMF probe that can be moved with a stepper motor. It's also got a home flag here so it knows where it is. This lid is still going to need holes drilled for the screw, so we mount the lid in the exact same place every time. Right now there's a calibration you have to do, but once the lid's screwed down, that should save a lot of time. So yeah, this hooked up to the EMF probe, just like you guys have always been using. I've got a bunch of extension cords here today so that I can actually reach the drivers. Once we have this thing up on the chamber stand, we don't have to have so many extension cables, and then the analog signal should work better and stuff as well. So on the hardware side, this is the actual control box. We've got 2 ribbon cables that go out to the drivers. We've got 4 current probe inputs that go down to the current probes on the mag drivers down there. Back here we've got our communication for the EMF probe. I normally provide 9 volts for it as well, so you don't have to use a battery, but the extension cable is not long enough, so we don't have that. It's just running off battery today. This is an output for the contactor. So I've got it wired up to a solid state relay right now. We'll use that to run the contactors whenever we have an AC box for this thing. Then at the end you've got your stepper motor, the stepper motor power itself, and the home flag. One other thing we've got over here on the side is SD card slot. I would like to set this up at some point. It's not ready right now, but to where it'll export all this test data into a CSV file, and you can put that into a nicely formatted spreadsheet. As it is right now, it's just on the screen. There's no SD card support, but we'll get that soon. There is one other issue I'm having right now. One of these probes is completely bad, and for some reason when I'm running the tests, it's not picking up any data for channel 2 or channel 4. So I'll figure that out and get that fixed, but as it is right now, everything else seems to be working pretty well. You can see we're getting fails on the current because the current probes aren't working right, but everything else seems to be going pretty well. So these are the actual test results. All the information is in here that you need to fill in the applied material test procedure tables. I don't know if you guys are actually doing that, but if you are doing that, the stuff is here. So there's the B coil plus and minus, the linearity between the two at 5 volts and plus and minus 5 volts. The B coil absolute, and then when we run the targets, you know, this is showing, okay, it was targeting 100, it hit 101.1, and that's a percent deviation of 1.1. So all the information's in here to fill in those tables if you guys need that. For other screens, well, let's just run through them, I guess. So that first screen that you just saw is run tests. That's the main screen that people are going to see, and you just hit the go button and it does its thing. Make waves. This is one you can use to put out wave patterns. Let me try the circuit breaker really quick. So the way you guys are using the current probes right now is you're doing a visualization on the O-scope to make sure the wave patterns look right. Since this is reading the current probes directly, you can just run the waves, and the top one is what it's outputting and the bottom one is what it's reading, and you can see that these are actually coming from the current probes. When I disconnect one, you lose a signal. So this is just like what you guys were doing with the O-scope, except now it's right on the screen. I don't know if you guys actually need to do this step. It's not called out in the test procedure, and we can set it up to just measure the current at each Gauss setting and make sure it's within a spec. That's easy enough to do. The code is already mostly there for that, so I don't know if you guys actually need the visualization, but if you do, it's here. You can also do square waves if you switch this. It's not the cleanest. I could probably clean up these current probe readings a little bit, doing some averaging and stuff, but I haven't really dug into that too deep yet. You can also change the rotation period, the samples per period, the amplitude and voltage, and the phase. There shouldn't really be any change of phase, but you can change all the stuff that you can change on the system. So we've also got direct control. There's direct voltage, so each coil, 1, 2, 3, and 4. You can set it. There's presets for positive and negative. Those are the ones that you normally use, +5 and -5. You can also type right into the text or use the slider bar. All those things work. It doesn't actually load the values until you hit the on button. So you hear the magnets turn on. And if you hit off, it zeroes everything and turns everything off at the same time. So that's direct control. If you want to do some direct control about the system, you can do it here. It also gives you the readouts for the Gauss meter and the current probes and all that stuff as well. The direct Gauss is pretty much the same thing, except you're running Gauss set points instead of current set points, or instead of voltage set points, but otherwise it's pretty much the same thing. It also turns on in pairs. You've got the coil 1-3 pair and the coil 2-4 pair, because when you're doing a Gauss setting, it's actually doing the coils in pairs, so that's that. Stepper control, not much here, just home position, go to different coils, run clockwise, counterclockwise, whatever. This is mostly just for testing. The count steps was just for initial setup. We don't need that anymore. Default settings, this I wouldn't recommend doing that unless you're actually going to do a clean, fresh installation, because it's going to wipe everything out and you have to learn positions and all that. And then learn positions, this one's important for the initial setup. The current, or the Gauss meter probe, is pretty sensitive to the angle, just a few steps off in one direction or the other, and you're not going to get the peak reading. So what this does is it lets you like go to coil 1, which is position A, turn the coil on, and then run a scan. And it'll run a scan based on 80 steps per move, and it'll find the peak, and then once it finds the peak, it'll let you save that to the flash memory so that it always knows, okay, this is where the perfect point is for position A or coil 1. And you can do that for each individual step or each individual position. You can also run it at finer. I found that 40 is about as low as you can go. Anything below that, it's just going to get the same reading on every sample, and it's not going to be able to find a peak. So if it's really far out, you can go all the way down to like 200 or 300 steps, but usually 40 or 80, that's going to be what you want to do. So you'll see it, yeah, it does the scan, it shows you where the peak is, and if you just hit save, it's going to take that peak and store it into position for A. And you can do that for all positions. Once the lid's screwed down, this shouldn't have to be adjusted anymore. But that's it for there. So yeah, that's pretty much the whole rundown, except for the current probes, which I think I can work out pretty quick. I think this thing is really ready to go. You guys can start testing with it, I would say, as it is right now. Just hook up the system if you want to use the AC thing for power. But really, once we get this thing on a chamber stand with its own AC panel and contactor and disconnect and all that stuff, it's going to be totally ready to rock. So anyway, that's it. Hope it saves you guys a lot of work.